Okay, so this is gonna be our last lab for the semester. I want to walk you through two exercises only, but in those exercises, we will need to write the pseudocode for them and be able to, oh, I forgot to add captions, sorry. And be able to prepare our code, right? I receive a lot of pseudocode from different students. Sometimes they do correctly, sometimes they need some adjustments. So we want to learn how to do this. Um, so I give you a little bit of general instructions. I'm sure you can find YouTube tutorials and other resources. So before you write your program, ideally you should outline your program. That would be involving putting down step-by-step procedure, or what we call that as an algorithm for your program logic to be able to prepare your program. And we would do this in your English language instead of a programming language. So that way you would have a better understanding of how you would code your program. So the steps for the pseudocode would start with first, you read the requirements for your program or the problem. In software, we would use programming language to be able to solve a problem. That's what you see with operating system, with application, with browser. All of those are software tools that allows us to improve our life or improve the process in how we use the computer. So ultimately, all software is really designed to solve a problem. And so first you need to look at what is being asked or what kind of problem is presented to you. For development, if you become a programmer or developer, in technical work in general, you will be asked to solve some kind of problem. So for software development, we want to look at the problem that is presented. And then what we want to do is we want to divide it up into small pieces. So that way, either you would incorporate functions to solve your problem, like calculation, um, or to be able to implement the task and the subtasks for your problem, such as I want to design a program that allows my user to make an order online for their food, right? And so in that, we would need to break down the smaller tasks. What would be incorporated for ordering online, how the user would be ordering. So when you break down the problem and the steps, you would need to ask the question, what, right? How and when. That's going to help you divide up your task. Then you need to incorporate logic. So we want to really focus on what is the main purpose of our program and how you would be able to declare your variables, your containers, right? That could be also array, and what type of variables and container that you would need. So like int, double, right? If we use large number, we want to use double. If we want to use whole number, we'll use integer. So those things we've learned. And then if we want to incorporate conditions, so if you want your program to look for certain criteria, we would then include if, else statement. Or if you want to have repetition, that means that we want to have iteration or iterative process. Or we want to, for our program to be continuous, we will implement while loop. Or if you want options, like we want to use switch case statement. So you have to ask yourself, how do I want to approach the problem? Do I need to have conditions? Do I need to have repetition? Do I need to have continuation in my program? Do I need to have options in my program? Then once you have an understanding, you want to incorporate that in your outline. And it's important that you branch because the processor actually look at these incorporation of your conditions and repetition to execute specific tasks in the case that it needs to meet a certain condition, or it needs to have repetition, or it needs to be continuous, okay? Then what we want is we want it to be clear, so you want to use indentation to show the steps. I recommend using like a list when you do an outline for your program. You don't have to use bullet, you can. You can also use numerical lists, or you can just go from start to the end without having a numerical list. But it needs to flow from top to bottom, right? Like just how the compiler reads your code. We want to think about how we would start the program and how we would end the program. And any sub steps or any smaller pieces of our program when we pseudocode is going to be indented so it's easy to see. And if you have any kind of output, you want to be able to include it. Like I will want to say display the result, right? Display sum. So that would be a cout in programming, but we want to actually include the output. So we know to be able to write cout in that section of our code. Make sure that it's clear and consistent. So if you're using a certain term to indicate your function, then make sure that we repeat that throughout. So that way it doesn't confuse people when they are using your outline. So what is the purpose of pseudocode is to help you prepare for your program. We're working on the last lab and we're looking at pseudocode explanation and steps. So in the case that if someone like a project manager, someone that is looking at the outline of your program, it's easy for them to understand. Okay. And you are going to use term like input, output, so that way it is consistent throughout. And we want to also use keywords like if, while, right? Those are the things that we can later translate that into our C++ language. So an outline of your program simply lays out how you're going to code your program. And this outline is known as your pseudocode. And then once you have a draft of it, you want to revise it. So many of my students tell me, well, I submitted my pseudocode, but I'm not sure if that's exactly how I'm going to create my program. That's okay. It's like how you outline your English paper, right? But sometimes you might add or subtract from that outline, and that's all right. It should be a working document where you can make adjustment, and then we want to use it to be able to check for errors or look for things that are unclear. And then we want to think about how is our algorithm? Is it efficient? Right? Did it meet the objective? Can it be improved? So that's kind of an important thing to think about. So your outline is a way that we can look back and say, okay, this is how I approach my program. This is how I build my code, but I can probably, subtract here, edit there, and improve it so that way it is efficient and it meets the objective better. Okay. Any question regarding the steps for pseudocode? And you can find this on Lab 9 document. So in the first example, the problem given to you, this is from our exercise this last week. Last week we did pointers, right? We started learning pointer and I reused the exercise. So the problem for this example is that two students want to exchange seats. One is sitting at number 12 and another is at number 25. And the problem requires that we swap the seats for these students. So this is how you would begin your pseudocode. You would have something to tell the people that you are beginning your program. And typically in this section, when we code it, you would include your libraries, right? Your header files and anything else that the language would require. So your program begins here. So the compiler at this point, it's going to load those library and prepare to read your compiled code. Then we would have a function definition at the top in which we can name it in our pseudocode if you want. You don't have to, right? So in this one, we name it. And we want to use pointer. We would say pointer seat A and pointer seat B. So we know that we need to add the pointer variables there. And then, yes, any question? And then we would have a temp variable, and we want to also incorporate the pointer. So when it say value at, that really indicates that we're using the asterisk, okay? And then value at seat A, so we want to have a variable called temp. Temp is, as is going to be representing the equal sign, so temp as, and we would add the pointer variable there. And then bring down the pointer variable for seat A, and we're gonna declare it as seat B pointer. So basically we point to different location where the value would be, which is gonna be 12 and 25. And then we're gonna point seat B back to temp. So this is gonna allow us to do the triangular movement like we talked about for the swap. So the function is going to be the mechanism to swap your seats. Then we are going to end the function. So you have to close your curly brace. And then inside your main, you would declare, right, your variable to hold seat 12 and your variable to hold seat 25. And then we would display the swapping. So when we do the display here, you know that it's going to be cout. And then we would then call the function. And typically, depending on the developer, so I suggest that if you do the function call, you should put in its parameter. So that way it's easy for you to code. And then after that, we do another display. So in the program, we would do a cout there. So we would display the seat after it's being swapped. Okay. And then we end the program. So that's how the pseudocode would look like. Now, some professor like myself, I would require my student to do either or. In this class for today, we're going to do both. So that way you know how. But in my programming class, I usually require the student to either do the pseudocode or the flowchart. Some people are visual learner and flowcharts work better for them. And so same thing as developers. Sometimes flowchart works better for people. And in the industry, typically you often see developer using flowchart more than pseudocode, but whichever works for you, you should use it. So flowchart is a way that we can visibly show the flow of our program from the first step, the beginning of the program, to the end of the program. So it would use shapes like, rectangle, oval, and also different arrows to show the sequence, the flow of your program from beginning to end. So in other words, it's just a diagram of your program. Now, if you have conditions and things like that, you also need to draw it. So to make a flowchart, first, you would need to think about the processes from the beginning to end, kind of like your pseudocode. And sometimes if it helps you, if you do pseudocode first and then flowchart, that's fine. And then from those steps, you are going to incorporate the activity. So you need to list those steps, and then also including like things that are repeating or things that are going to go back to the beginning, like a do while. And then the sequence of your steps. So you need to make sure that you arrange it in order of the flow, right? Like if I would start my program, I would define a function, and then at some point that function would be called in the main, right? And then you would assign them the symbol. So There are common symbols that would represent a flowchart, and I would show you at the end. It gives you a table on what kind of shapes you're going to be using. And you would connect the symbols using arrows. Okay, there are tools online that you can use to do the diagram for your program or the flowchart. And then at the end, you can refine and review your flowchart. So similar to pseudocode, but in this case, when we do a flowchart, it's just adding shapes that would visibly show the flow of your program. Okay, so what are the shapes? You can use pill or the oval as for the end or the start of your program. So where you have begin in pseudocode, right, you would say start, and then at the end of your program, so you can use oval or your pill shape. Any kind of process like your function, right? The step that need action from your processor, you need to use a rectangle. And then diamond is for branches, like if else statement for decision making. So if you say if, right, the value is greater than 0, then you need to put that into a diamond. And then for the parallelogram, that will be for your I/O, for your C in and your C out, your input and your output. And then the arrow just going to help us go from one shape to another to show the flow of your program. So you can use physical tool like paper, whiteboard, etc. to prepare. But in this world, you should use online tools, right? So I include a list of online tools along with some application you can use. I recommend using diagram tool because they already have template for you. So what I'm going to use is I'm going to use this tool right here, and I can show you how to start it, and I can show you my flow chart so that way you can create it. Okay. Now, is this important? Some, like I said, some classes professor will will require you to write it. I require it for my programming projects. And also if you work with developing team, writing programs or technical team, you have to do a flowchart or pseudocode or both. Okay. So here is an example of what it would look like for a simple program. You would have a start. So you can use oval or pill, that's up to you. Depending on the tool that you use, sometimes they would have specific shape. And then anytime that we declare a variable, that's a process because the processor cuts, right? It creates the memory space for the variable or the container and its value. So you put that in a rectangle. And then you connect the shape with the arrow. You're just going to go pointing down because it's going to flow top down. Almost all programs are sequential program, unless if you do Python parallel programming, that is a little bit different, but that's another class. However, so when we declare the variable or container like array, you put that in the rectangle. And then if you want to do display, you can do it this way, or you can add, right, the appropriate shape. So it talks about the parallelogram. So you can use parallelogram, but it can also be a process because we're going to do a C out here. So that's up to you. Okay. And then if you do a function call in the main, that is a rectangle again. And then so in that case, it's going to process the swap, right? Temp to CA and then so on. And then we are going to display after swapping and then the end. So it's really simple. Okay. Now in this program, we don't have branching, so you don't have if else statement, but in the case you do, just gotta make sure that you would branch with the rectangle. I think in the prior notes and my lecture, you have seen how the if else statement diagram is drawn from the notes part of the exercise, right? So you can add the diamond and then you would go yes to the left, right, to the right and a yes, no, left and right, and then be able to branch it accordingly. Okay, So the code, we saw this from the previous exercise on how to swap the seats. So the process is that we would create pseudocode or flowchart and then write the program. But most of my beginning students, they tend to write the program first and then do the pseudocode. You can do that, but you will come across challenges in that sometimes you will get stuck with your coding and then you don't know how to go about solving that problem, right? So we want to have a clear understanding of how we solve the problem before we code. That's the main goal. Okay, so let's do exercise 1 together. So similar to what you see with the example, we're going to do a swap mechanism for using pointer. You have 2 stock prices. The first stock, the price is $150.25 per share. The second stock price is $98.25 per share. Let's say that we own this company and we want to swap the price. We're going to take the price from stock 2 and put it in stock 1, and stock 1 put it in stock 2 before we release it into the market, right? So first we're going to write the pseudocode for our program, and then we're going to create our flowchart. And you can use what is given to you in the example to be able to write it. So here we go. I just use the same as the example and then I modify my function a little bit to make it easy. And the program that you are doing is actually a dynamic allocation memory program. When you do a swap like this, in the concept is called dynamic memory allocation. Okay, so we would start with the word begin. You can say start, that's fine. That tells us that our program is going to start where it's going to load the libraries. And then you are going to define your function here. And I decided to call my function swap dynamic. You can call it swap stocks, right? Swap price, whatever you like. So we want to give our function a name. Then from there, we want to put in the parameter. We want to say pointer A and pointer B. So that way we would use the asterisk accordingly when we put the pointer into our parameter for the function. Then we would have a temp variable, and we would say temp as value at A, because there's stock A and stock B, A for stock 1 and B for stock 2. And then the mechanism for the swap, we would say value at A as value at B, right? So we know that this part is going to be our pointers. And then on the last swap step, we would say value at B as temp. So first we take temp, point to A, then we take A, point to B, and then we take B, point back to temp. So you have a triangle, right? I call it the triangular move. And we would end the function. The reason why I put that is so that I would close my function with my curly brace. And here we want to, in the next part, this is now going to be our main. I didn't put main, but we want to allocate dynamic memory for stock 1 and assign it the price that was given in the problem, 150.25. And so that means that we want to, because it's a numerical value that has a decimal like this, you want to use the double type in your C++ program. Then for the second line, we're going to declare stock 2 and we're going to assign it 98.75. So the same thing. You don't have to put allocate dynamic memory, but we want to declare our variable here. You can say declare stock1 variable, stock2 variable, assign these values. Then we're going to do a display before the swap. And then, so that means that we're going to do a cout here. And then we're going to display stock1. And we're going to display stock2. So in this part, we simply put down the pseudocode, which is the requirement for our program, right? For our exercise today, the step-by-step. And then next, we're going to do a function call. And so we just simply say call and then bring down your function name. And our variable, our parameter is going to be stock1 and stock2 as you previously defined. So very close to your example that you see for pseudocode, you just need to change up your variable, right? And your function name. And then after you have done your function call, you want to display the outcome, which is going to be your stock prices have been swapped, right? So we're going to display stock1, and here we want to say value at. Again, we're going to use our pointer and its reference here and in the next one. And you can do it on one line, you can do it on 2 lines, that's really your choice. And then don't forget the word end to end your program. So that means that, or I'm sorry, there's more. You are going to do, let me zoom back out because some of you are still working on, let me put it at 180 or 150. So we would have deallocate memory for stock1 and deallocate memory for stock2. That would be your return 0. So it gives back that space to the computer. And then we do an end at the end. So you start and you end. I've seen many pseudocode that was submitted to me that's incomplete. I think it's just because some classes don't really address this thoroughly. I want to make sure that you know how to do this in the case you have to do it or you need to do it for work or for school. Okay. So you notice that we're using display continuously for cout, right? So you want to be consistent. You can use output as well. You don't have to use display. But display tells me that I need to do a cout there. Now, there are also applications online that allows you to convert your code to your pseudocode, right? And sometimes pseudocode to code, but it's not very clean. So you still have to finesse it and refine it. I know I'm fully aware of that, right? I'm also aware that you can convert from programming languages to programming languages. You can also ask AI to perform a lot of these tasks, but the point in this is to teach you how to be able to approach your problem and break it down into the steps so that way you can solve it. Because when you interview for jobs, that's what typically is required in the technical industry. Cybersecurity, IT, programming, you need to understand the problem and solve the problem. Whether, stopping malware or writing a software. Okay. Are we okay with this? Any question? Okay, so part of exercise 1 is to create your pseudocode for the first exercise. We want to have the start, right? The begin and the end. Okay. Now, let's try to do a flow chart. Okay. See you later. I know your name. Okay. So the next step is we are going to do the flow chart, right? You have a choice of the tools that's given here. Some of the tools you have to register for an account before you create. Some of the tools you have limited drawings, like they'll give you 3 or 5 free drawing before you could you could sign up for an account. And then so you simply would click the link here and be able to open up the web app. And I have kind of doing a start for you already, but let me delete this and delete this so I can see. So I use the first link, which is for diagrams.net. And you would have what they call a canvas space right here. This is a cloud-based, web-based tool that you can create. You can also name your diagram. There are other diagrams and flowcharts, other templates that you can use if you go to the main website. You can, after you create it, you can also download it or take, as an image file. So what we're going to do is we are going to create the start of our program. So I'm going to drag this rounded rectangle. You can also use an oval or an ellipse. So let's do that. Let's use an ellipse. Drag it onto your canvas space. And if you double click the shape, you can say start. If you double click the shape, you can just type in the text that you need to add. Okay? Now, if you want to color your shape, you are going to, so there are some options up here on your tool. So make sure that you select your shape and then you can click on the paint bucket and you can put in the color of your choice, right? You don't have to do the color. Now, if you want the arrow, just click the arrow. And it's, because the way that they have it, you need to rotate this. So we're gonna, oops, Control Z to undo. And if you need to delete, you can press backspace. Okay. Or you can click the delete button up here. So I'm gonna go ahead and make sure that I select my arrow. So when my cursor becomes the 4 arrow direction, I can drag it and then I can turn it downward. And I just need to connect it to my shape. And you can resize it if you want. There you go. So in our program, right, we have these steps. So next is going to be our function right here. So that's going to go into the rectangle. So you can copy and paste this into your flowchart if you want, that you already did the pseudocode. Okay. Like this should be into 2 rectangle. So next, we're going to drag the rectangle, click it. You can click it or drag it, and then you can resize it. And then once you have the rectangle after your start, this is exercise 1 flowchart we're working on, you can double click the rectangle and you can type it or paste it. So what I'm going to do is I'm going to add the part from my pseudocode, right? And I can copy that and add it to my flowchart. So that's the convenience of Oh, maybe it doesn't let you. Let me see. It should. Maybe having to do Control V. Yeah, if you do Control C and Control V, you should be okay. So the convenience of having the pseudocode already, you can just bring it over to your flowchart and then add another arrow. So when you're done, we are going to just snip it and add it to our document, right, as an image. You can also save your diagram, and then if you create an account, you can later download it. Yeah, I think after it does not like the, let me see if I paste it. Okay. So you get the idea of how to draw it, right? Drag the shape in. So if you want, you can add things like this. I had copied the image earlier. Now, you don't have to use the rounded rectangle for the display. You can use a parallelogram if you have a parallelogram on your app, right? So we can say, we can have a start, which is what you see that I had done that here. And then we can also, yeah, let me delete this portion. Let's do it again. So we want to say we want to assign value for stock 1 and stock 2. I'm just going to summarize it. You don't have to say dynamic library. So stock 1, assign value, right? As 150.25, and then stock 2, assign value as 98.75. Now, can I do this in Microsoft Word? You can, right? If you click Insert Shape, you should be able to draw it directly in Microsoft Word if you want. You don't have to use an online app. You can also do that on Google Doc or PowerPoint for Microsoft. So there's option like Insert, and you can see that there are shapes here that you can also add. It's not as nice as what you see with an online tool, but you know, it is useful. Okay, so we have a start at the top, then we have assign value, then you can do a display before the swap, display stock 1 and stock 2. And then we do a function call. So we know that main calls all the other functions, so you know the section when you code it, that should be main right here. And when it does the call, it's going to process the swap, right? It's going to go to location A to plug that into the temp. The value from location A is going to be in temp, and it's going to do the swap. So B point to A point to temp, and then temp point back to B. So once we have the mechanism for the swap, we are going to display our stock price after the swap. Then we do a return 0 for deallocation of memory. So we free back the space. And then lastly, you just have the end. And that's how you do a simple flow chart. Now, if you have if-else statement, you would include it, right? And so if yes, go left. If right, if no, go right, right? You can add those, the arrows to branch off accordingly. So it will look like that. Sorry, my start thing got cut off. I try to get everything in one image. And you don't have to fill the shape with colors. And you're not just limited to an online tool. Like I said, you can use Microsoft Word. That will be under Insert Shape. And you can color your shape, add text to your shape by double clicking it. It should allow you to type in your text. And what we want is we want to kind of outline it so somebody can visually look at it and say, oh, this is how the program should go from the beginning to end. And as you outline, sometimes you can make adjustment, like you would think of maybe I can add something or subtract something. And then after you create your flowchart, you can also go back and refine it. So it's not a permanent thing, right? We can change it over time. So your software should be modified over time as you see that there's many different versions of your programs being released throughout time. Do you have any question for me? Okay, so since all right, I try to zoom it back in so it's easy to see. I know some of you sit farther away. So if you look at the example program, you can just follow the example program, just change up some information that would meet the program problem, right? The exercise 1 requirement, and then be able to implement that. Keep in mind that, you know, every questions or every exercise probably have different problems. So we want to be able to use the flow chart to solve the problem as we go. That's the goal. Okay. Any question? So I want to also let you know, since most of you are here, if you have outstanding work, missing assignments, make sure you get them to me by the finals week. Okay. I know Miss McQueen likes his thing open until the 19th. I will close your grade on the last day of class, which is the 18th. Okay. And make sure you get your assignments to me by the 7th. If you need to submit it, you know, after that, you need to contact me. I need to get your grades into your transcript by the following week. And there's going to be a lot of people on, you know, the holidays time off. So I want to make sure if we have any kind of problem, we want to address that. Final exam will be released the second week of December on Canvas. I will be here in class if you want to come in and take the exam. Make sure we complete all the tasks. You should check your grades, and if anything that is missing, like a 0, you need to turn them in, and so I can grade them and update the grade, okay? A letter grade will go to your transcript, so if you have, like, let's say a 95 in the class, then you will get an A, right? So following the standard college scale. Make sure we complete the final as it is required, right? And you can just log into Canvas to do that. If you have any problem questions, you can come to the class time. I will be here. You can also email me or send me a Canvas message. Like if you can't access it for some reason, but it should be available by that Monday. I also have 5 other classes to submit grades, so make sure that you get those things in, and no late final, okay? So make sure you complete final on time and get all your assignments in by final exam time. And I will be here the week before final, same as I would be required for your class time. So it's if you have things that you need to catch up with, and if you need help, you can come and see me. Come to class and then I can help you. Okay. Okay. Now let's look at the code, right? I know some of you already start running your code as so we would need pseudocode, we would need a diagram or a flowchart, and that was the stock price one. And then we would need the program screenshot. So like all the other program, we would have include IOStream at the top using namespace std. Then we have a function called swap dynamic, as you saw that in your flowchart. I have my pointer with the type here, so double A and double B. And I would have a double temp is going to be A, and A is going to point to B, and B points back to temp. So that will be my function. Then in the main, I want to declare the pointer for stock. So now you probably haven't heard of the new keyword yet. But what you can do is you can use the new keyword to instantiate another object, and you can pass the actual, this is for the new C++ language, right? So you can use new as a keyword at the type, and instead of a variable, you can pass the value directly into it. So because this is a location in memory called stock1, and so it ties the address to this. And instead of pointing it and dereference it, you can use the new keyword and use the value inside the parenthesis this way. This allows us to implement what's called dynamic memory allocation, because we can tie the value to an address of our RAM and be able to point to it, okay, which is what we did here. So unlike what you've seen in the other program, in this one we use dynamic memory allocation, and we would implement the keyword new. We would do the double, and then we can instantiate the value for that memory location. If you're using the new here, by rule for all objective languages, including Java, C++, you need to give back the space. So you need to delete it because what it does is it creates an address location. It's kind of like building a house and putting the people there, right? When you're done with your program, you want to get rid of it. So because C++ is not very good at garbage collection, some of you probably know about garbage collection. So garbage collection is a process in the computer where when things are given back, things are used in the program, right? It needs to put that into the garbage and then reuse that space from the recycle that location, right? So we want to have in some languages like Python and Java, garbage collection is better as it uses different mechanism to build the program. Like it has a virtual machine with the compiler for Java. And Python, it uses an interpreter. So it does a better job at collecting the garbage, right? Because if you don't delete the location, what will happen is that you're going to fill up the buffer in your computer, and then eventually you're gonna run out of RAM. Okay. So it's like, you know how if you are renting a house, right? At the end, you're gonna clean up that house and give it back to the condition that how you got it. Um, so you can get your deposit back, right? Same thing with the car. This is the same thing in programming. If you are using the space, then we want to give back that space to the system so that way it can reuse that for another program. Okay. So if you're using the keyword new here, you need to do a delete at the end. If you are taking 17C later on for data structure in computer science, which you will in order to transfer, you will have a lot of practice with this, right? Using object and then creating that object, which is tied to a memory address, and then deleting that object when you're done. So technically, we're just using an address location for our object and then put a value there. Okay. So after we display the before and the after, right? So we would display the before, call the function so that way it does the swap for us and display the updated value here. Then we just get rid of the location, the actual container at location. We give that back to the system and we do a return 0 and we're done. And that's how you can do dynamic memory allocation in C++. And in this, it's not too advanced. In some cases, you're going to have classes, right? If you implement data structure and other things, that's going to be better. But this is the beginning. So if you are required to write a dynamic memory allocation program, you would use pointer. You would use the keyword new to instantiate your container with the value, and you would remove those locations when you're finished. Okay, that's the key. So when I teach Java, there's a chapter that I go over where they create object and same technique and same keyword, right? But you would use a class object because Java, you have to have class. C++ have classes too, but we don't have to implement it right off the bat. Java, you do. You have to implement class. So, and C++, that's the key difference between C++ and C, is that C++ has class and C doesn't. So if you learn this here now, right, you would know how to implement dynamic memory allocation. So that's why in your pseudocode and your flowchart, we want to include dynamic memory allocation. Any questions? Okay, so we learn now how to implement this technique. When you finish, you can test and run your program, right? And then see if you have the right output. And anytime that you're asked to swap values, this is probably the best approach. It's actually doesn't take up the memory location and permanently store things there, right? We use it temporary, and then when we're done, we give it back. That's the goal, is that you're gonna free up the space so that way you don't fill up the buffer. And the more buffer that you use on your computer, the more memory that you use, the slower it's going to be. Because, and this is why they say that, if you're gaming, buy more RAM, it's because you need all of those addresses to be able to have more of like the animation, the graphics and then if you use GPU, the cache on the GPU, the size of just the memory on your GPU, your video card or your graphic card, the higher the amount of RAM that you have on it or the memory that you have on it, the VDR, then you actually have better graphics, right? And then the processor that comes with it. And each processor has internal cache, internal storage that's used. So those components are important. This is what you see from the software side, because on the software side, we actually just use those memory location, put values to it, and then use the values for calculation. That's it. Okay. Any question? So what we did was we created pseudocode for our program, right? We created a simple flowchart for our program. So you can just do screenshot of your flowchart and your code. And then we have the code itself. So this is how you build your program, right? In computer science. Okay, next. Any question regarding exercise 1? We'll do exercise 2 and we'll call it a day. I know I have like about close to an hour with you, but hopefully you get to finish in 30 minutes. Okay, so let's go to the next exercise. You can do the same thing. You can reuse your flowchart and just update it. Jane wants to swap 2 travel destination in a booking app. Destination A is Paris and destination B is Hawaii. Create pseudocode and flowchart and write a C++ program to use pointer to swap and display the updated travel destination. We need to create pseudocode, flowchart, and our C++ program. So let's start with the pseudocode. You can edit the pseudocode that you have, and so that way you can see. Let me put it on. I have the flowchart at the beginning, and you can work on your flowchart after your pseudocode. So the same thing as the last pseudocode, I start with begin, or you can also type start. And then I define the function. Instead of swapping stocks or swapping dynamic, I call it swap destination. And I use pointer D and pointer D1 and D2 instead of A or B. So we can change it up. Everything else is practically almost the same. So we want to say temp is value at D1, value at D1 as value at D2, just like what we did with A or B in the other program. Value at D2 as temp, and we're going to end the function. So the body of your function, you can indent it in, right, a little bit or more. We are going to declare our destination. The first destination, destination A, is going to be Hawaii, and destination B is Paris, or vice versa. That's up to you. Just make sure you follow your code accordingly. We want to display both of these destinations before we swap. So after we display the original destination, we are going to do a function call here. So this is part is for main. And then we're going to display after the swap. You can do dynamic memory allocation with this one, right? Or you don't have to. And then you end. If you do dynamic memory allocation, remember we would just use the keyword new, and then we're going to do to delete the location at the end. And that's the true difference, right? And then we instantiate those values for the object. Okay, so I'll put it back up a little bit for those of you who, so I have begin, let me shrink it back up, right? After we define our function, we declare our variables. That's going to hold Hawaii and Paris. Once we declare, we are going to display. Then we do a function call. After we swapped it, with the function call, we display the swapped location. And then we end the program. That's it. So that's how you create a pseudocode for your exercise 2. Very easy. And I tell my students, right, for my programming classes, I read their pseudocode, and if it doesn't have branches, things like that, like I would give them feedback. But they, the point is to make sure that it outlines the specific for your program. So if your program have loops, it needs to have the loops incorporated, like while for, do while for C++, or if else statement. Okay, you're good with pseudocode now? Let's look at my little diagram. So the flow chart, I would do a start, right? I would have initialize Hawaii and Paris. So you can use the web app or you can use Word. And I can demonstrate that in Word for you if you like here. So if we want to draw it like this, go Insert, Shape, and then you can select your shape, right? I'm going to do an oval for the start, and Word actually, it has, let me move this down a little bit. It has like a pre-filled templates for you, and you can also change the color, right? So if you do this in Word because you have a Word document to work with, you can. And then if you want to add text, you can also insert text box inside it. You can also change the color. So if I click on double click the shape, I can change this. So if I want to go like a lighter green, I can do that, right? So I just do a shape fill in Microsoft Word. You can use the link that I have provided for you in the notes for the tools part. So you can do it that way. And then you can add, right click, and then you can choose add text. And then you can do a start. And if you want to change the font, you can highlight it. And then you can go to, I think, home, and we can change back our font to automatic. Oh, because it's actually the shape format. So just click the font at the top. So I can do a start. And then if you want the arrow, click the arrow and then draw the arrow down like this. So you don't have to use the online tool. And then if you want the rectangle, just do a rectangle. I'm just not gonna fill this one. So we want to say right click, add text, and we can say initialize A, right, as Hawaii. Now, if you use Google Docs, similar steps in adding your shapes and adding your text, online apps for diagram and flowchart, some of them already have pre-made templates, so you can just fill them out, right? Which probably streamline the process for you. Let's shrink this a tiny bit so you can see. Also, the reason why we look at flowchart is that in the case that if you become, let's say, a debugging programmer or developer, software engineer, you will likely read, right? You might need to look at the design of someone else's program. Many companies buy programs that are pre-written programs from somebody else, and then they would modify it or customize it. And you could be that person that you need to do the customization. So you need to look at how they lay out their program. So you typically they would give you the documentation. So the flow chart or pseudocode or both would go into a documentation. And then if you look at some GitHub repository, GitHub mostly just contain code, but some documentation would include like the outline of their program, which is your flowchart. Okay. Like I said, doesn't have to be 100% permanent. It doesn't have to look extremely pretty, but it just needs to be clear. Okay. Concise and clear. So we want to depict the flow of your program. And then, if you're using pointers, you can just include the asterisk. If you're using or if you are dereferencing, or if you're using reference, you can just say, how you want to implement that. Like we want to have addresses to be able to pass those as address instead of an actual variable. Can we do this with the regular variable and not having to use pointer? Yeah, you can do a program like that. It won't be as efficient or dynamic as what you see in how we use pointer. The whole point in using pointer is it helps your compiler to perform the task in an efficient way and faster, right? So we care about performance and resource usage in programming. Okay. Are we okay with flowchart? You want to look at the code now? You can modify the previous program or look at the example. But what we'll do is we are going to look at my project. Okay, so as you saw in my flowchart, right? The reason why we have to have string is because it's the name of our travel destination, Hawaii and Paris. Can I include string up here? You can. If you don't, C++ compiler would be okay with not having the STL up here, standard dynamic library up here. If you want to, or STL, right, your standard library up here. But if you include string, that's okay too, right? That's up to you. So I have a function called swap destinations, right? And in that I would pass pointer D1 and pointer D2, and they store string, so you have to type it. It contains text, the name of the city that Jane is visiting, or she wants to travel to those, right? Then we have a temp variable, and the temp variable is also going to store text, right? As we swap the two city. So string temp, and we're going to use D1 to point to temp, then D2 point to D1, right? And then D2 back to temp. Then in your main, you would then declare your destination. So we would have string, destination A is Hawaii, and destination B is Paris. We would then display the destination before we swap. So we would do cout, and A is going to be destination A, and B is destination B. So you can do it in one line or two. That will be up to you. After we display the original destination, we would call the function so that way we can swap them. And so in this one, unlike the previous exercise, you can do the way that we did exercise 1, but this one we are going to use reference. So we are going to use the ampersand. That's what you've seen last week. And that is allowing us to reference the value or the string here. So we're going to reference the text that was declared in destination A and the text, which is Paris, that was declared in destination B. So it's going to plug those in to the parameter here. And it's going to switch. It's going to swap. And it's going to process this. Then we're going to display the outcome for the swap and complete the program. So this one is not a dynamic memory allocation program. It's simply just use pointer and dereference those pointers. Okay. So if you want to do dynamic memory allocation, if that's a requirement for a job interview, then you need to use the new keyword and you need to use the delete keyword to delete the location when you're done. So I want to remind everybody, today is the last required assignment and the last required attendance. I will be here the following week after Thanksgiving. No school next week, but after Thanksgiving week, I'll be here. So in the case you need help or have questions, you can pop in. Use that time to prepare for your final exam. and catch up with work if you have outstanding assignment. As I see them, I will update your grades. And then hopefully by final exam, you would have more of a overall grade and then add it with your final grade, then you would have the grade added to your transcript the following week. So for each exercise, we need to include our pseudocode, our flowchart, and our the screenshot for the flowchart. You can just screenshot it, and the screenshot of your program in C++ and output. And we don't have to answer any more questions, but I wanted to kind of highlight the things that we've learned today, right? We reviewed how to use pointers today. You were introduced to dynamic memory allocation technique in C++ using the new keyword and delete keywords to be able to create memory location and use it for your function, your program, and then be able to remove those location at the end of your program. You also learn how to do pseudocode, which is a way that we can outline our algorithm for the program. So for those of you who are transferring to the UCs, right, I'm pretty sure that they will likely put you through some kind of boot camp or the coding camp, they call it, to assess your programming skills. And it starts with, building your algorithm and then be able to code it. In different languages, like UCLA would be Java and some C++, right? Davis or other places would be likely C++ or even Python. Same thing with San Diego or Berkeley, and some CSU also implement coding camp. So you need to kind of understand the basic on how to write your pseudocode or create the flowchart so you can work on building out your program. It's just a way that we logically solve the problem and be able to implement. So we learn how to use online tool to do our flowchart or even do it in Microsoft Word, right? So I wanted to just kind of share this and touch base in this class because I want to make sure that you're prepared or at least know how to do it if you need it. Okay, any question? And I hope that all of you have a good Thanksgiving break, right? And I might see some of you when we come back. Like I said, I will be available during class time for help. But make sure we study for final and get all the work in. And I hope to see some of you in future classes. Because I do teach a couple classes in computer science. So, all right. Let's stop recording real quick.